Row 1. Text, Notepad window, text editor, editing, end of line. Remember, this is not teaching man teacher. It is useful for recalling, when exam coming man student. Just close eyes and listen. Based on G scheme for Electronics Engineering Group. Subject, Audio Video Engineering, 17,537. These are mostly important questions which is always repeat. Form top to end it reduce repeated changes. X question 1 is more important than 2 in notes. And note warning sign that this is not all chapter.
Audio Video Engineering Chapter 3. 1. 3. Define the following terms with respect to TV system. 1. Hue 2. Saturation 3. Chrominance signal 4. Brightness ANS. 1. Hue 1 mark. This is the predominant spectral color of received light, which means it is the actual color seen by the eye. Red, green, blue, yellow, magenta, represent different in the visible spectrum. 2. Saturation 1 mark. It represents the spectral purity of a color light. It is the amount of white light that is mixed with a color. A fully saturated color will have no white light mixed with it. For example, a pure red without white is a saturated color. 3. Chrominance signal 1 mark. The combination of hue and saturation is together called as chrominance signal. In color TV 4.43 MHz color signal is chrominance signal, which has all the color information. 4. Brightness 1 mark. Brightness or luminance is the amount of light intensity, or the total amount of light energy that is received by the eye irrespective of the color of light. In monochrome TV, better lighted parts have more luminance than dark areas, and different colors have shades of luminance. Resolution. The scanning and reproduction of the finest details of the picture is known as resolution of TV system. 1. Contrast 1 mark. This is the difference in light intensity between black and white parts of the picture over the average brightness level. 2. Luminance 1 mark. Luminance is the amount of light intensity, or the total amount of light energy, that is received by the eye irrespective of the color of light. In monochrome TV, better lighted parts have more luminance than dark areas, and different colors have shades of luminance. Aspect ratio 0:1 The aspect ratio of an image describes the proportional relationship between its width and its height. The frame adopted in all television systems is rectangular with width/height ratio, i.e., aspect ratio equals 4/3. Aspect ratio equals width of the screen/height of the screen equals 4/3 image continuity, 0:1 While televising picture elements of the frame by means of the scanning process, it is necessary to present the picture to the eye in such a way that an illusion of continuity is created. Audio Video Engineering Chapter 3. 2. And any motion in the scene appears on the picture tube screen as a smooth and continuous change. 2. Scanning the scene is scanned rapidly both in the horizontal and vertical directions simultaneously to provide sufficient number of complete pictures or frames per second to give the illusion of continuous motion. Instead of the Z4 as in commercial motion picture practice, the frame repetition rate is 25 per second in most television systems. 4. Pixels. A pixel, short for picture element, is the smallest active element, or dot in an image. A well-defined picture will be general have more pixels than in less defined one. Interlace scanning. The scene is scanned rapidly both in the horizontal and vertical directions simultaneously to provide sufficient number of complete pictures, or frames per second to give the illusion of continuous motion. Instead of the Z4 as in commercial motion picture practice, the frame Repetition rate is 25 per second in most television systems. 3. Bandwidth of color signal, 1 mark. The color subcarrier frequency is restricted to about plus 1.2 MHz around the subcarrier. The brightness signal is transmitted with full frequency bandwidth of 5 MHz for maximum horizontal details in monochrome. B. Compare additive color mixing with subtractive color mixing with respect to any 4 points. ANS, 4 points. Audio-Video Engineering Chapter 3. 3. E. State any 8 CCIRB standards for color signal transmission and reception. ANS, any 8 standards 1/2 mark each. I. What is meant by flicker? How flicker is eliminated by interlaced scanning. Explain. Flicker, 1 mark, although 25 to 30 frames per second are sufficient to give continuity of motion in a movie scene, the dark interruptions between bright pictures become visible as flicker because persistence of vision increases as brightness decreases, hence, a frame is scanned twice, using the interlaced scanning technique. In this system, the scanning lines of one sequence fall in between the lines of the previous sequence. This gives 50 interruptions per second and eliminates flicker. Diagram, 1 mark, interlaced scanning, 2 marks. In TV pictures an effective rate of 50 vertical scans per second is utilized to reduce flicker. Total numbers of lines are divided into 2 groups called fields, even and odd, as shown in figure above. The first sequence of scanning starts from leftmost. Audio-Video Engineering Chapter 3. 4. Ends on middle on last line. The vertical retrace is shown by dotted line deflects the electron beam from bottom to top shown by dotted lines, which takes 1.280 milliseconds, equal to 20 scanning lines, are blanked in retrace. The second sequence of scanning stars from this middle point, and ends finally at the rightmost point bottom, after completing 605 th line. A. Define the term resolution with respect to TV system. Explain the term horizontal and vertical resolution in detail. ANS. Resolution, the scanning and reproduction of the finest details of the picture, is known as resolution of TV system. 1 mark, vertical resolution, 1 1/2 marks. The ability of the scanning system to resolve picture details in vertical direction is known as vertical resolution. 1. Vertical resolution is a function of scanning lines into which the picture is divided in the vertical plane. 2. The maximum number of dark and white elements, which can be resolved by the human eye in the vertical direction, in a screen of height h decided by the number of horizontal lines into which picture is split while scanning. 3. Thus, vertical resolution can be expressed as VR equals not asterisk K. VR equals vertical resolution not equals active number of lines K. Kel factor, or resolution factor. Horizontal resolution, 1 1/2 marks. The ability of the scanning system to resolve the picture details in the horizontal direction is known as horizontal resolution. 1. While aiming at equal vertical and horizontal resolutions and assuming the Audio-Video Engineering Chapter 3. 5. Same Kel factors. The effective number of alternate black and white segments, n, that get scanned in one horizontal line, are n equals not asterisk aspect ratio asterisk k. E. State TV channel allocation for band I and band 3. ANS. The carrier frequency should be chosen 10 times of highest modulating frequency to get better selectivity at RF, and if tuned amplifier in the receiver. Highest frequency for picture signal is 5 MHz. Hence, the carrier frequency is always greater than 40 MHz. TV transmissions is generally in VHF and UHF. VHF band equals 30 to 300 MHz. UHF band equals 300 to 3000 MHz. Lower band VHF channel, band I has 3 channels 2, 3 and 4 from 47 to 68 MHz higher VHF channels, band 3 channels 5 to 12 from 174 to 230 MHz VHF band, I 47 to 68 MHz, channel width equals 7 MHz. VHF band 3, 174 to 230 MHz, channel width equals 7 MHz, 2 marks. Audio Video Engineering Chapter 3. 6. E. Define vestigial sideband transmission. State its any two merits and demerits. ANS, define, 2 MKS, merit, 1 MKS, demerit, 1 MKS. The picture signal is amplitude modulated and sound signal is frequency modulated before transmission. In 625 line system, the video signal frequency components are from 0 Hz to 5 MHz. In double sideband AM transmission is used, bandwidth required will be 10 MHz. Actual bandwidth is more than this due to practical filter characteristics. Practically it is not possible to determine the bandwidth abruptly, so guard band of 0.5 MHz on each side should be given. In addition to this, 0.25 MHz is given for sound transmission on upper side. This together with forms channel bandwidth as 11.25 MHz using doubled sideband system. To reduce bandwidth and power transmitted vestigial sideband system is used. In this full upper sideband transmitted and vestige, or part of lower sideband transmitted, which results into reduced bandwidth to 7 MHz. Merits, any two. I. Bandwidth is reduced so that more number of channels can be accommodated in a given frequency spectrum. 2. Power saving of 50% possible at transmitted power is moderate. 3. Filter design becomes practicable so circuits used are not costly complex. 4. No distortion occurs and no loss of low frequency component results in less interference. Demerits, any two. I. A small portion of transmitter power is wasted in the vestigial sideband filters, which remove the lower sideband. 2. Signal-to-noise ratio is slightly less than what it would be in total DSB. Because in the vestigial sideband signal, the lower sideband frequencies from of 0 to 0.75 are present in both sidebands, while the rest of the frequencies from 0.75 to 5 MHz are present only in one sideband. 3. The low video frequencies contain the most important information of picture, is if the lower sideband is completely suppressed then there is distortion, which is manifested as smear in the picture. A. Describe the neat sketch how interlaced scanning will help to reduce the bandwidth of the video signal. ANS, diagram, 2 MKS, explanation, 2 MKS, to reduce flicker, an effective rate of 50 vertical scans per second is utilized in television picture system. This is accomplished by increasing the downward rate of travel of the scanning electron beam. By increasing downward scanning rate, every alternate line gets scanned instead for every successive line. After the 1 st scan the beam reach the bottom of picture frame, the beam quickly returns to the top to scan remaining lines which are missed in 1 st scan. Thus the total number of lines in picture frame are divided into our two groups called Audio Video Engineering Chapter 3. 7. As fields. Each field is scanned alternately. This is called as interlaced scanning. This is like reading alternate lines of a page. It reduces flicker, which results in reduction of bandwidth and noise. Figure shows principle of interlaced scanning. In this vertical retrace time is considered 0, and horizontal retrace lines are not shown for convenience. This figure shows 625 lines. TV system. A frame of 625 lines is divided into two fields having 312.5 lines each. Each field is scanned alternately to cover the entire picture. In first field, 312.5 odd lines are scanned only, which is called as odd field. The scanning sequence is 1, 3, 5, 7. After this the beam spot returns to the top of the screen, and remaining half part of the 313th lines and all even number of lines are scanned. This is called as even field. The scanning sequence is 2, 4, 6. To achieve this, the vertical sweep oscillator, sawtooth waveform, made to operate at 50 Hz frequency so that two successive interlaced scans make up the complete picture frame. This method reduces flicker, but at high brightness levels interline flicker observed. Also bandwidth and noise reduced. Sometimes interlacing error occurs if the lines of even fields are not exactly in the middle of the odd field. This will cause pairing of lines which results in jagged picture giving silky effect or fishtail. Interlacing error results due to error in starting of first line of the even field. Even field does not starts exactly at the middle of the picture frame. Because of this, uneven spacing between the lines of two fields occurs. It is caused due to an open capacitor in the integrating circuit, or by an open decoupling capacitor in the vertical oscillator. Audio-Video Engineering Chapter 3. 8. B. Describe why equalizing pulses are required. Draw the vertical synchronizing pulse structure. ANS, diagram, for MKS, explanation, 2 MKS, this is a half-line difference just prior to the start of serrated vertical pulse. This 1/2 line difference does not affect the horizontal deflection synchronization, but it does affect the vertical synchronization, and the interlaced scanning. The effect of uneven line period can be reduced by increasing the interval between the preceding line pulse and the field sync pulses. To ensure that the vertical deflection oscillator receives the necessary triggering voltage at the same time after every field, a series of 5 narrow pulses 2.3 µs each, occurring at half-line rhythm, are inserted before the field sync pulse. These are called pre-equalizing pulses. The width of equalizing pulse is normally half the width of horizontal sync pulses, roughly half of 4.7 microseconds, or 2.3 microseconds. The equalizing pulses inserted after the vertical synchronizing pulses are post-equalizing pulses. These equalizing pulses do not disturb the operation of either oscillator, yet they permit the vertical sync pulse to occur at the correct time after every field. Audio-Video Engineering Chapter 3. 9. A. State Grassman's law. Draw the sketch of additive mixing. ANS, statement 2 marks, diagram 2 marks, statement I perceives new color depending on the algebraic sum of red, green, and blue light fluxes. This forms the basis of color signal generation, and is known as Grassman's law. The eye is not able to distinguish each of the color that are mixed to form color, but instead perceives only resultant color. For example, yellow can be produced by mixing 30% of red and 59% of green. Red, 30%, plus green, 59%, equals yellow, 89%. Red, 30%, plus blue, 11%, equals magenta, 41%. Purplish blue, 11%, plus green, 59%, equals cyan, 70%. Greenish blue, red, 30%, plus green, 59%, plus blue, 11%, equals white, 100%. Luminance. A. Draw composite video signal of one line, and state the function of following. I. DC level 2, blanking level 3, wider than white 4, pedestal height. 8 MANS, diagram function DC level. The video signal has an average value, or DC component corresponding to the average brightness of the scene. In the absence of DC component, the receiver cannot follow changes in brightness. Blanking level, the level above which the picture information is invisible on TV raster. Audio-Video Engineering Chapter 3. 10. Screen. The blanking level starts at 72 to 75% of total amplitude of picture information. Wider than white, the level below which the picture information appears as a white spot on TV raster screen. The whiter than white level is at 0 to 12.5% of total amplitude of picture information. Pedestal height. Pedestal height is the distance between the pedestal level and average value, DC level, of the video signal. This indicates average brightness since it measures how much the average value differs from black level. B. Explain the details of horizontal sync pulse. ANS explanation 02M out of a total line period of 64 microseconds, the line blanking period is 12 microseconds. During this interval a line synchronizing pulse is inserted. The pulses corresponding to the differentiated leading edges of the sync pulses are actually used to synchronize the horizontal scanning oscillator. This is the reason why in Fig. 3.3 and other figures to follow, all time intervals are shown between sync pulse leading edges. The line blanking period is divided into 3 sections. These are the front porch, the line sync pulse, and the back porch. The time intervals allowed to each part are summarized below, and their location and effect on the raster is illustrated in Fig. 3.3. Audio-Video Engineering Chapter 3. 11. Diagram. E. Describe the importance of pre- and post-equalizing pulses. Explanation. 2M each, to take care of drawback which occur on account of the half-line discrepancy. 5 narrow pulse are added on either side of vertical sync pulses. These are known as pre-equalizing and post-equalizing pulses. Pre-equalizing pulse. They are of 2.5 microsecond duration, results in discharge of capacitor to essentially zero voltage in both the fields, despite half-line discrepancy, before the voltage built-up starts with the arrival of vertical sync pulses. Post-equalizing pulse. It is necessary for fast discharge of capacitor to ensure triggering of vertical oscillator at proper time. A. State and explain primary color and secondary color. Grassman's law for color theory. 4M. The eye is not able to distinguish each colors that are mixed from colors, but instead perceives only resultant color. For example, yellow can be produced by mixing 30% of red and 59% of green. Audio-Video Engineering Chapter 3. 12. Eye perceives yellow color depending on the algebraic sum of red, green, and blue light fluxes. This forms the basis of color signal generation, and is known as Grassman's law. White has been seen to produce by adding red, green, and blue lights. The intensity of each color may be varied. This enables simple rule of addition and subtraction.